Okay, let's continue discussion of complex numbers. Uh, Complex number has a plus bi. Now let's talk about the special property of I. I has a property square is equal to -1. Okay, let's talk about its powers. The powers of I. Of course, the first power is just I itself. And then the second power, by its definition, it should be -1. Okay, then the third power means it's a second power times I. Second power is -1, so the third power is -I. Alright, and the fourth power is I squared times I squared. I squared is -1, I squared is -1. You get the product -1, you magically have 1. Okay, so the first four powers, first power I, second power -1, third power -I, fourth power 1, and fifth power is I to 4 and times I. I to 4 is 1, it's nothing, so it's just I. And sixth power is I to 4 times I squared. I to 4 is 1, so it's I squared. I squared is -1. Seventh power, I to 4 times I cubed. I to 4 is 1, I cubed is -I. Eighth power, I to 4 times I to 4. I to 4 is 1, I to 4 is 1, the product is 1. You see here? I, -1, -I, and 1. And this I, -1, -I, and 1. It's repeated. You can expect that after 8, 9, 10, I9 is going to be I10 is going to be -1, I11 is going to be -I, I to 12 is 1. It's a periodic. It's periodic. The period is 4. Every 4 times the values of the power will repeat. Alright, so this is a very, very interesting and special property for I. With this property, we can do the following examples. So for example, we have I to 27. How do we get the value of I to 27? We clearly will not do the product 26 times. We do the following thing. We separate the multiples of 4. 27 is the closest multiple is 24. And times 3. I to 24 is always 1. You see, 4, 8, 12, 16. Whenever you have a multiples of 4, it's always 1. So you just get I cubed. I cubed is -I. Alright? And second, I to 101. I to 101 is I to 100 times I. I to 100. 100 is the multiple of 4. 100 is 4 times 25. So this is 1, and you times I is I. Okay, so let's continue this. For example, this year is 2020. For 2020, we know that 2020 is a multiple of 4. Yeah, so 2020 is a multiple of 4. So it's I to any multiple of 4 is equal to 1. I to 2020 is equal to 1. All right. Okay, next. If we want to simplify 3 plus I cubed, 3 plus I cubed, we want to write this in the standard form. And for this type of thing, a plus b cubed, it is a cubed plus 3a squared b plus 3ab squared plus b cubed. This is a useful formula. Okay, this is a useful formula. And with this formula, let's see. A is a 3, b is a I. So it's 3 cubed plus 3 times a squared is 9b plus 3, a is a 3, b squared is I squared, and plus b cubed is I cubed. Okay? 3 cubed, 27. Squared is 9 times 3, 27. 3 times 9, 27i. 3 times 3 is 9. I squared is negative. I cubed is negative I. So 27 minus 9, 18. 27i minus I plus 26i. This is the standard form. Okay, this is a standard form. Okay, so that so far we discuss a lot of property about the complex numbers in abstract. In this moment, let's try to connect the complex numbers with the quadratic equations. Solve quadratic equation. In the complex number system. Okay, so before we solve it in the complex number system, let's extend our definition. So if n is a positive number, for example, like let's see just for example, if n is 10, then we define the following thing. We define the principal square root of negative n. For example, here negative 10. We define the principal square root denoted by square root of negative n as square root of negative n. You see, we separate them. It looks like square root of n, square root of negative 1. We separate them. But it's not that way. Okay? It's not that way. We just understand it like we understand it this way, but we define it as square root of negative n as a negative n times I. Okay, it's a negative n times I. No middle step, just directly go this way. Okay? So we understand like we separate them, but it's just understanding, but by the definition it's like that. Square root of negative 1 is I. Okay, so now we can take square root. For example, square root of negative 10 will be square root of 10 times I. Square root of negative 4 will be square root of 4 times I. Square root of 4 is 2, so it's 2I. This is so-called the principal square root. A principal square root. It's not the square root. Square root, you will have 2 square root. Okay, so what do I mean? I mean the following thing. If you have x squared equal to 4, you will see x is plus or minus 2. Plus 2, positive 2 is called the principal square root. Negative 2 is a counterpart, right? And if you have x squared is negative 9, then x is going to be, first you get the principal square root and then put plus minus sign. And this is a plus minus square root of 9 times I, square root of 9 is 3, so it's plus minus 3i. So still, for the abstract quadratic equation, this simple quadratic equation, you will have 2 solutions. But this time you have 2 complex solutions, right? So when you solve it and get a complex number, we say they have, you solve the equation in the complex number system. Solve the equation in the complex number system because your result is a complex number. If we say we solve the equation in the real number system, then this one has no solution. Okay? Has no solution in the real number system. Okay, but it has solution in the complex number system. Okay. Here there is a warning, a very small blur, but it's a very important warning. You don't do any crazy thing. What do I mean crazy? For example, you have 100. 100, it can be written as a 25 times 4, or it can be written as a negative 25 times negative 4. And then let's continue this. We take square root of 100, it's 10. And it can be written under the square root as a negative 25, negative 4. Okay, it's this way. But it's not equal to square root of 25 times square root of negative 25 times the square root of negative 4. Why? You see here, if it is equal, I say if it is equal, let's continue. Square root of negative 25 means square root of 25 times I. Square root of negative 4 is a square root of 4 times I. Square root of 25 is a 5. Square root of 4 is 2. 5 times 2 is 10. I squared is negative 10. See? You will get a crazy result. So when you have this notation, square root of AB is equal to square root of A times square root of B, this formula only for AB are positive. Positive or 0, non-negative. This property only works for positive or non-negative numbers. It does not work for negative numbers. Okay, so that's a property. When we talk about the square root property, we have some stuff under our mind. It's positive. Okay, so whenever you're handling negative square root of negative numbers or imaginary numbers, be careful. Don't make some crazy equation. Okay. Okay, now let's really solve the quadratic equation. In the theorem, what is the quadratic formula? Ax squared plus bx plus c equal to 0. Then x is negative b plus or minus square root of b squared minus 4ac over 2a, right? This is a quadratic formula. And in the last section, when we talk about this quadratic formula, we call this discriminant. We say discriminant positive, 2 real solutions. Discriminant equal to 0 are double solutions. Discriminant is negative, no solutions. But this time, if we solve this in the complex number system, when this discriminant is negative, we can still get a complex solutions. Okay, so this is actually a complete formula if we consider in a complex number system. When I say complete, it always gives us a solution. This is a complete formula in the complex number system. Always have solution. Okay, then let's see. For example, we have x squared minus 4x plus 8 equal to 0. Solve it in the complex number system. Solve it in the complex number system. So a is a 1, b is negative 4, c is 8. So x is 2a negative b plus or minus square root of a b squared minus 4ac. 4 times 1 is 4 times 8 is 32. Right? 16 minus 32 is negative 16. If we're talking about real numbers, we will say, okay, there's no solution, real solutions. But here, once we already discussed complex numbers, this is a 4 plus minus square root of 16 times I. Square root of 16 is a 4. This is a square root of positive number, it's a 4. Over 2, so 4 over 2 is 2, 4 over 2 is 2. So the equation has two complex solutions. 2 plus 2i, 2 minus 2i. See, you always have the solution for this one. You can go back to verify it. It is definitely the solution. All right, so now let's summarize the discriminant situation in the complex number system. In the complex number system, for ax squared plus bx plus c equal to 0, then 1, b squared minus 4ac positive, there are two real solutions. Different. B squared minus 4ac equal to 0. There is a double real solutions. 3. B squared minus 4ac is negative. There are two complex solutions. Those two complex solutions, you see 2 plus 2i, 2 minus 2i, they are conjugate to each other. Okay, so this is another way to characterize the solutions of a quadratic equation. All right, so for example, let's compute it. Let's just use example to examine all three cases. So example. So if we have a 3x squared plus 4x plus 5 equal to 0, then the solutions is 2a negative b plus or minus square root of b squared minus 4ac. B squared minus 4ac, which is 6 negative 4 plus minus 4 times 3 is 12. 12 times 5 is 60. So it's a negative 44, right? So there are two solutions, negative 4 plus, plus negative 4 plus square root of 44i over 6, and negative minus square root of 44i over 6. two complex solutions, right? And second, if we have a 2x squared plus 4x plus 1 equal to 0, then x is 2a negative b plus or minus square root of a b squared minus 4a and c. 4 times 2 is 8. 16 minus 8 is 8. So it has two solutions, negative 4 plus square root of 8 over 4, and then negative 4 minus square root of 8 over 4. Right? There's two real solutions. And the other one, C, 9x squared minus 6x plus 1 equal to 0. Then x is 2a negative b plus or minus square root of a b squared minus 4ac. Okay, 4 times 9, 36. 36 minus 36, square root of 0. Just 6 over 18, 1 over 3. So x is 1 over 3, 1 over 3, sorry. 1 over 3 and 1 over 3. A repeated roots, plus 0 and minus 0. A repeated or double root. Alright? So at this moment, with the help of a complex numbers, we can completely study or completely solve the quadratic equations. Alright? So do the exercise, try to understand the concepts. If you have a question, send me email. Okay, so we finish this short video. We'll continue in another video. Thank you.